Hi, if you're watching this, oh, okay. Is this the part where I say if you're watching this, that shows I'm not around? Sound like someone left like some will or instruction when they die or go to the space. Anyway, I'm alive, just out of school, as you know. Anyway, so for today, the idea to be done is IGCSE idea, area of triangle, and sine rule for the double lesson. So I want you to do the area of triangle for the first lesson and the sine rule for the second lesson. When we meet tomorrow, we will look at the extension of sine rule. IB expected to do ambiguous case, which was not done in IGCSE. We'll look at that tomorrow. I'll explain what I mean by that. And then we go to cosine rule on Thursday. And that will be the end of our solving triangle. Yeah, with some bearing maybe. So let's go to area of triangle quickly. So basically, you know how to find area of triangle with half base times height. That is the basic approach of finding area of triangle. Or what if that is not available? So what you know is when you are asked to find the area of triangle that looks like this, or that looks like that, as long as two perpendicular sides are given. So here it's obvious this is the base and this is the height, but here it's not so obvious. So you can call this your height and this your base again. You can call any of these your base times height. So base times height doesn't mean the base is where it's sitting on. Base and height are actually two perpendicular sides that you can see in this kind of picture. But in a picture like this is your base and this is your height. So as long as you can get a base and the height or any two perpendicular sides, you do area is equal to base times height divided by 2, or some might say area is equal to half base times height. Whichever way, you are fine. Then this is the basic approach to finding the area of triangle, the normal approach. I use the word normal because that's something we know from primary school. Now that we are grown, we need to learn other ways. What if they are not provided? Now that you have learned the SOHCAHTOA, then it is necessary to introduce to you how to find the area of triangle by trigonometry. So that's what we're going to do. Okay. Now, given a triangle, I should say area of triangle by trigonometry. Of course, from the word trigonometry, you know we are going to be dealing with SOHCAHTOA, right? Are we dealing with all of them? Are we dealing with one of them? You will see in a bit. Suppose you have a triangle that is not right angle, okay? And suppose you have the base B, and instead of the height, you have the slant side. The slant side may be A. I don't want to use the word A, so it doesn't look like adjacent. It doesn't sound like adjacent. Let's call the base X, base Y, something like that. So in addition, then you have an included angle. We call this included angle. It means the angle between the two given sides. So rather than giving you the base and height, if this was our base, then we're expecting this height, but we don't know what it is. If we are to use this as our base, then we're expecting this height, and then we don't know what that is as well. So rather, you have these two sides and the included angle. So we're going to come up with a formula, which you only need to remember. Let me see if we have it in the formula booklet. If you have it in the formula booklet, then lucky you. Okay, still looking. Wow, it's in the formula booklet. You are so lucky. Anyways, but let's try to understand the idea, because what I'm trying to do also by the end of the lesson is not just for triangle. It can be extended to parallelogram, trapezium. Of course, rhombus is a special type of parallelogram. So of course, rhombus like that. So that's what I'm trying to do. So it's not enough to just say, oh, it's in the formula booklet, I don't need to understand it. Try to understand the idea. Now, if this is the case, then let's see what we can do. So this is my triangle again. This is my X and this is my Y. This is my angle theta. I could try to draw my perpendicular myself and try to find it at H. Okay. It's not enough to say this and these are equal unless this and this are equal, unless you have an isosceles triangle, right? So if the triangle is not isosceles, this line is not a line of symmetry. So we cannot say these two triangles are equal. Okay, and as a result, you cannot say these two sides are equal. So this cannot be y over 2. That's what I'm trying to say in essence. So basically, we don't have any information about this because we don't know how much of the line has been demarcated by this point. We don't know what proportion of the entire line is this one. Okay, since we do not know that, then we can as well just forget about that part. What do I mean by that? We will only consider these parts. The only part that we know is that this is X certainly, this is theta certainly, this we know nothing about it. And we are trying to find the unknown height. Okay, since we do not know anything about this, we forget it. So let's deal with our SOHCAHTOA based on the available information. This will be our opposites. This is the hypotenuse, and this is the adjacent because of this theta is here. Okay, then from here, you will realize that, oh, actually, sine theta, which is opposite over hypotenuse, implies that sine theta is h over x, which implies that h that we need is actually s sine theta. The implication of this is that the area that we're actually looking for, we know that area is half times base times height. So this time around, our area will be half times. Our base is y. Our height have just been found to be x sine theta. And that led to the new formula. Area is equal to half xy sine theta. Now, what does this mean? This means that if we are trying to find the area of a triangle, given two sides and an included angle. When we say included angle, we mean the angle between the two sides. The area is simply half times the product of those two sides times the sine of the angle between them. That's what we are trying to say. Half times the product of the two sides and the sine of the angle between them. That's what we are talking about. Okay. So this implies that properly. This implies that the area is that. So basically, if you have this shape, P, Q, and R, and this is theta, this is alpha, and let's say this is phi. So area can be found in three ways. Area will be half PQ sine phi. Maybe I write that as part of the notes. I was going to erase this. So I'll say that is given the triangle below, with theta, alpha, and phi, where the sides are P, Q, and R. Area, if you use P and Q, the angle between them is theta. So it will be sine theta. The same area can be found if you use P and R. The angle between them is phi. The same area can be found if you use P, Q, and R. The angle between them is alpha. That's what we are talking about. So this is similarly extended to other shapes, like I said earlier. What do I mean by other shapes? Talking about parallelogram. So this could be extended to a parallelogram. If you have a parallelogram, set this idea could be extended to a parallelogram and even trapezium. So let's look at parallelogram first. This is a parallelogram. Normally, you're supposed to have the base and the height. If you are given the base and the height, you say that the area is equal to base times height. However, if you are not given the base and the height, rather you are given the base and the slant side instead of the height. So you have the base and the slant side. A. So again, we do what we did before. You try to find your height yourself. Of course, when you're given that slant side, the included angle theta will be indicated, will be given as well. So that's like the replacement. Instead of giving you base and height, you're given base and the slant side and the angle theta. Again, sine theta is going to be opposite, which is height h, hypotenuse, which is side A, which implies that h is equal to a sine theta. So the original formula, base times height, will simply be base times a sine theta. And that is why for parallelogram, the area can be calculated as, which implies that area is simply AB sine theta, which means product of the two given sides and the angle between them and the included angle. Okay. Similarly, a trapezium. So I'll just quickly go through that also. Similarly, a trapezium. You know what a trapezium looks like? A trapezium looks like this, right? So suppose you have, of course, we call this A and B, the formula for trapezium. So let's say you're given this slant side and angle theta. If you are given this angle, you should be given this side. Okay? Unless you have isosceles trapezium. Isosceles trapezium is the one which the slant sides are equal, then the base angles will be equal. Isosceles trapezium, just like we have isosceles triangle. Okay? Now, without this, let's get rid of this first. Without this, the area of a trapezium with height h, perpendicular height, the area is given by, I'm sure you remember this from my GCSE or middle school, a plus bh. That's the formula for area of a trapezium. Okay, but given the slant side instead, and in an included angle theta instead of h, of course. So our trapezium will look like this. Again, I could put it on this side, but just to change the side. So slant side C, this remains A and B. Okay. Then we can do the same thing. Try to find our H. using SOHCAHTOA. Sin theta will be opposite in that triangle, which is H, hypotenuse, which is C, which implies that H is equal to C sin theta. And then the area of a trapezium, which was A plus B times H, will become area is equal to half A plus B C sin theta. So you will notice that whenever the slant side is given instead, it replaces the H. The product of the slant side and the sine of the included angle replaces the H. What do I mean by that? Let's see. The first one, we have x sine theta. Here you have x sine theta. So is the product of the sides and half of the product of the side sine theta. You know, normally it should be half base times height. Where is that? Okay, normally it should be this. So instead of base times height, you have the product of the slant and the product of the two sides and the sine of the angle. Let's put it that way. For this, instead of base times height, it becomes AB sine theta, where A and B are the sides, and theta is the angle between them. Okay, and for this one, instead of A plus B times H, it becomes A plus BC sine theta. You can see a pattern here. So this is the approach of trigonometry to finding the area of a triangle. Okay. Now, the last thing that I want you to do, so if you look at your worksheet, I have it here. I printed it on the school computer. Let's see if I have it here. A sec. I have it online drive, so you can open it here. Recent. Yeah. So I share my screen now. This is the worksheet you should have. You can see if these are your A and B, and this is your theta. These are your A and B, and this is your theta. Just make sure your calculator is in degree mode. For isosceles triangle, you can have two sides equal, and the angle is there. For equilateral triangle, you only need two sides and the angle between them. In equilateral triangle, you have all the sides and all the angles, so you choose whatever you want. Parallelogram, just like I said, okay? Then you can reverse it by solving this. I believe everybody knows how to solve, so there's no need to give example. Again, you always quote your formula. You quote your formula, you show me your substitution, and you show me how you made that missing stuff the subject of formula. Please do not use your calculator until you get to the last point. What do I mean by that? I've seen a lot of you using your calculator to find sine something from the second step or tan something from the second step. That will give you an approximate value, which will be wrong. So do not use it, okay? I'll show you what I mean by that. So if this is my triangle, and maybe the area is 24, maybe this is 8, this is theta, maybe this is 6. Okay, let's change that to 9. So area is the first thing I expect to see as your solution is area is equal to half AB sine theta. The next thing I expect to see is 24 equals to half times 8 times 9 sine theta. Of course, you are welcome to simplify this as 4. So you have 24 equals to 36 sine theta. And you have your sine theta to be equal to 24 over 36 and arc sine, something like that. No need to put this in decimal. If you simplify 2 over 3, your choice. If you don't simplify, you're good. Then your theta will be arc sine like we did. Now, look at this situation. Maybe the area is given as 24 again. Maybe theta is 30 degrees. Maybe this is, no, let's change it to 60 degrees. Maybe this is still 8, but this is unknown. Again, I expect to see area is equal to half AB sine theta. So this is 24 equals half times 8 times x sine 60 degrees. This is going to be 24 4x sine 60. Don't press your calculator and write 0.8660. No, because this number extends indefinitely. So the moment you use this, you are still going to divide at some point. So you're already approximating the first step. You are deviating from the exact value. So leave it as that. Come here and say x is equal to 24 divided by these two terms. At least to isolate this, you have to divide by these two. Okay, so you have your 4 sine 60. Now this is what you put in your calculator. Because you see, this is going to be 6 divided by sine 60, right? But if you have approximated this, your division will give you an approximation, but you're already using an approximation to do the approximation. So that is a premature approximation, which will imply that your answer will deviate a bit from the final correct answer. So that is not a good practice. Okay, so go back to what I shared earlier, the worksheet. So please, and these are applications, so think about it, collaborate among yourselves. Okay, hexagon is a 6-sided polygon. I said regular hexagon. So what do the regular hexagon look like? You have 1, 2, 3, 4, 5, 6. A regular hexagon will consist of 6 equilateral triangles. Okay, 6 equilateral triangles. So the area of that regular hexagon is simply 6 times area of triangle. That's all you have to do. That is going to be 6 times half AB sine theta. Okay, so explain in this way so we know what you have done and do the needful. Okay, so of course you know what the angles are. They're 60, 60 each. Okay, and all these sides are equal. All these are equal. They are regular, right? All the sides are equal. Regular hexagons consist of 6 equilateral triangles. Okay, 6 equilateral triangles. What else do I need to chip in something? I give you this particular question I need you to try. This is not hexagon. This is a regular pentagon. Pentagon means 5-sided polygon. So these triangles are not equilateral triangles. So you need to figure out what they are. Okay. Now the last thing that I want you to learn is called the Eros formula. This does not require a proof because the idea is not necessary at this point. I'm just going to state it and tell you how to use it. Okay, so area of triangle by Eros formula. Now, the previous formula, trigonometry, is used when you have 2 sides and the angle between them. Eros formula is used when you have all the sides. Even if one of the sides is the height, you can use Eros formula. The criteria for Eros formula is that all sides must be known. So if you have a triangle like this and the height is not given, but you know all this ABC, you're good. Okay? If you have your equilateral triangle with all the sides given, you're good. So which means equilateral triangle can be done by Eros formula and also by trig because angle 60 is known. Okay? So you should practice with both approaches. So for Eros formula, let the sides of a triangle be A, B, and C. We call S semi-perimeter. Semi-perimeter. That is perimeter divided by 2. So that's A plus B plus C divided by 2. So by Eros formula, area is simply the square root of S bracket X minus A, S minus B, S minus C. That's all. So the square root of the semi-perimeter Then semi-perimeter minus each of the sides all multiplied together give you the area of the triangle. Let's check. Let's check. Let's make use of the equilateral triangle. Let's say an equilateral triangle of side 4 centimeters. If you use the trigonometric approach, your area, because all sides are equal, right? And all angles are equal. So your area is half AB sine theta. You see I stated my formula and I write area. I didn't write half AB sine theta. If I don't see that description, it's poor mathematical communication. And you know this is IB. All those things are very important criteria. So sine 60 degrees. And if you check in your calculator, well, I just use it in exact form to save time. So this is going to be 2 times 4. And 60 is root 3 over 2. So basically the area is 4 root 3 square. And put in the calculator whatever you get. By Hero's formula, the first thing you find is the semi-perimeter. So that is A plus B plus C divided by 2, which is 4 plus 4 divided by plus 4, of course, or 4 times 3 divided by 2, and that will be 6. Because it's perimeter, like it's perimeter, so it's a one-dimensional stuff, so it's centimeter. Then the area. Again, the first thing I expect to see is the formula. I don't care if you are doing the question 10 times, write the formula 10 times. That's how you remember stuff. So that will be the square root of, the semi-perimeter is 6, so you have 6 minus 4 in 3 places. Okay, and that is simply the square root of 6 times 2 times 2 times 2. Again, if you check, this must be 4 root 3. Okay, so that's all about area. Thank you very much. Do your work. You can watch the video in class, you can watch later. Please do your work and please copy the notes into your notebook. I'll send the worksheet, the notes in PDF to the Ed module, to the WeChat group. Okay, bye.